Okay, good afternoon. Assalamualaikum. Today we will start on the new topic, which is the combustion appliances in chemical processing. Okay, last class I have requested for you all to do the exercise based on what are the combustion appliances in the chemical industry. Okay, later on we will go to discussion to discuss on that exercise. Okay, now I will only give you a brief overview on the combustion appliances in the industry. So basically, we know combustion occurs in a combustion chamber. So those combustion chamber, it can be a furnace, or some of it you'll find in incinerator, heat engine. Okay, so basically furnace, it has few designs of furnace. Okay, as you can see from here, okay, furnace design, it has a few types of furnace. From this slide, okay, here it shows three types of furnace. Each furnace mainly consists of insulated refractory line chamber, okay, containing tubes. There are convection tubes over here. Okay, and there are also radiant tubes, whether it is on the side or in the middle of the furnace. Okay, this type burners, vertical cylindrical. This type of furnace, it has this kind of radiant tubes, horizontal, vertical radiant tube, whereby for this type of furnace, you will see different type of radiant tubes. Okay, so the arrangement of the radiant tubes differentiate the different type of furnace. Okay, but the function is all the same, to burn or to combust the fuel. Okay, the tubes carry the process fluid to be heated. For example, in a boiler, so this tube contains perhaps water, okay, or steam. That will be required to be heated. The burners burn the fuel in air to generate flame and hot gases. Okay, so here you will have burners where fuel will be injected over here. Fuel and air. Okay, burners can be floor mounted, wall mounted, or roof mounted, depending on the design. This type of furnace, it has double fire, so that means the radiant tube is in between the burners. Okay, in between. For example, if this is in the boiler, so the tube is in between the burners, whereby this type of furnace, okay, for example, the tubes of the boiler, it is arranged this kind of arrangement, okay, horizontally, or later on you will see the design of boilers as well. Okay. Now draft. What do you understand of the draft? What is draft? What is draft? Draft is an equipment to push or pull the air into the combustion chamber. Okay, draft is the difference between atmospheric pressure and the static pressure of the combustion gases in the furnace. So it, let's say for example furnace, the air, if you don't use any draft, the air will flow at atmospheric pressure. So flow naturally. If you have draft, you will push in the air towards the furnace to supply at certain temperature, certain pressure of air. Okay. Now for the draft, they have 4 types of draft as well. We have forced draft, induced draft, balanced draft, and natural draft. We go one by one. I show you the okay, for the forced draft, it operates with the air and combustion products maintained above atmospheric pressure. So the fan at the inlet of the furnace called forced draft. So that means it pushes in the air at the specific pressure. It supplies the necessary air for the fuel combustion. Okay, so it must be sized according to the stored air-fuel ratio that you calculate. That's why the importance of the air-fuel ratio. How much air per kg of fuel used. Okay, that one is forced draft. Induced draft is below atmospheric pressure. Induced draft, it operates with air and combustion below atmospheric pressure. Okay, it creates sufficient negative pressure to establish a slight suction to the furnace. Force is above, induced is below the atmospheric pressure. Okay, so again, it depends to the location of your furnace and the design of your furnace. Okay, balanced draft is a combination of forced draft and induced draft. This reduces flue gas pressure and the tendency of combustion gases to escape the furnace. Okay, so it controls the combustion that occurs inside the furnace. Okay, so basically this draft is, I would say, essential equipment for the furnace. Okay, let's just watch this video. For example, the explanation on the draft.
safety check is doing a combustion check, which is this combustion.
Okay, so it is the draft is also as important of the process because it controls the air input and also the flue gas output of the flue gas. Okay, as he mentioned just now, if the pressure is not stable, so it will push out the flue gas inside the environment. Okay, instead of pulling out the flue gas towards the environment. Okay. Okay, we move to the furnace section. For furnace section, it has few sections. Okay, two distinct heating section where you have radiant section. Okay, combustion chamber of the firebox and convection section. Radiant section, this is the part radiant where the combustion occurs. Then convection section, okay, this part, the convection section. Bottom part is radiation, upper part is the convection. Okay, sometimes they have a third section known as shield or stock section. Shock section, okay, here. It depends on the design of the furnace as well, whether you require this section or not. Basic construction of furnace. Okay, basically you will have a burner down here, then the radiant tubes, whether it is vertical or coil types. Okay, and this on the convection bank. Okay, this is the convection part. What type of tube and how is the arrangement? Okay. Now, example for furnace applications. Now we move to the exercise that you have done last week. Is Lam Xuan here? Lam Xuan, okay. Can you discuss what you have submitted over here? Okay, we discuss what you understand from what have you did. Question 1 will be the two types of combustion appliances. Question 2 would be the description. Okay. Burners and incinerators, the two type of furnace. Okay. Now question 2, can you explain a bit? What kind of fuel that can be used for burners? Huh? Fuel. Hydrocarbon, solid, gas, liquid, both, all can. Okay. Okay, what does it mean by air stage? Air stage burner. Come again? Mm-hmm. One or more additional stages of air. That means the air input is in stages or what? Okay. Here, that means you inject the 100% of fuel. Then you control this equipment, what I can understand, inject 100% of the fuel. Then you control the air input. So here it shows over here partial combustion, where perhaps not enough air is being supplied. Then the air enters in stages until the combustion completed. Okay. How about incinerators? Any diagram? Right? Okay, incinerator, what kind of fuel that can be used? Liquid phase. Okay, incinerator is either liquid or gas can be used. Okay, any type of fuel. And then what's the difference between burner and incinerator? Close burner. How about the rest? What do you think? What is the difference between burner and incinerator? Kam Jayan, what do you think? What? Uh-huh. Mm-hmm. Okay, infant is actually a burner. And my question is, what is the difference between burner and incinerator, right? No difference because incinerator is a combination for the whole system. Incinerator is a whole system. Burner, here is the burner. You need to use the burner to burn this waste, right? So incinerator is the whole system. Okay, burner. So burner here is you inject the fuel and combustion occur over here. So for the incinerator, burner at this part, you inject the fuel and occur the combustion over here. So incinerator is the whole system where the waste being dumped on the burner to be combust, right? So is the waste over here considered as fuel or not? Is the waste considered as fuel? No, why do you say so? Okay, waste over here, the one that being combust is not the fuel. Cannot be considered as the fuel. This one is the the item that being combust. Fuel is the one that being used to generate the fire, right? So the waste actually can also be used as fuel, but the position is not here. It should come from the source of the ignition. Okay? Okay, so this one is burner and incinerator. Now let's move to Kang Zisheng. Is here or not? Not here. This one who? Which one is this? Anyone? No name. Wait, let me see. Abdul Karim. Just keep quiet over there. Okay, can you please discuss a bit? Two types of equipment involving combustion. Furnace and steam boiler. Okay, furnace. Okay, what you understand from this diagram? What type of fuel do you think they use over here? Huh? Coal. Okay. Then the temperature is around here. Okay, furnace run at a high temperature. More than basically 700 and above. Okay, then this one, what is about this diagram? Okay, this is the fire. This one combustion process for what? What is this? What is this metal? Iron slide. Is this iron slide? Okay. Okay, the concept is furnace, correct? You must identify what is the fuel use. Okay, when I mentioned this question, explain the equipment stated. So explain the furnace. Explain means you need to explain about the equipment and about the process. What kind of fuel that you are using? What type of fuel? How do you need to determine the air? Okay. And then for what process it is used? This combustion process used to combust what? What is the purpose? Okay, so that's how you answer the question of explain. Okay, explain. Usually explain will bring a lot of marks. You will need to explain the process with certain keywords. Provide diagram. Yes, you should draw the diagram as what you understand of the process. Okay. Why is it skull over here? Dead man. Burning dead man. Oh, this is scary. And okay, so we move to steam boiler. Okay, can you explain a bit this diagram? Okay, so the combustion occur whether inside the boiler or outside the boiler to heat up the water. Okay, then the heated water or heated steam from here will be supplied to other process line. Okay, we have heating unit as well over here. Steam heater. Okay, so the combustion might occur over here at the boiler. Boiler also, it has a few types of boiler. Okay. Okay, the explanation here explain for the combustion process at the boiler. So that means the combustion process occur at this place. Okay, so the combustion occur at here. The description over here refers to this part. So the rest of the line over here, it explain the flow of the heated steam. Okay. Okay, thank you. Now this one is Brahim, right? Now can you please explain a bit what you did over here? From the slide, okay? So explain a bit. What do you understand of the furnace? What you write here? You should understand what you write. Mm-hmm. You just copy the slide. Okay, this one as per explained earlier, there are few types of furnace, and this is the basic design of furnace where you have burners, uh, radiation area and convection area. Draft is not one of the combustion appliances. This is essential equipment attached to the furnace. Okay, where it is you control the air input. Okay, next, Loshini is not here. Kam Jayan and Fu Xinyi. Okay, explain a bit what you have explained. What have you submitted over here? Furnace. Okay, correct. Thank you. Next one. What is CCGT? Okay, this one used in what process? Power plant. What is seawater doing over here? Oh, they use seawater. Condenser. Sure. Okay, anyone understand the purpose of seawater over here? To what? To? To separate temperature of the stream. Steam. Reduce temperature of the steam. You mean chill water. To use as chill water. Okay. Agree? This one from this diagram lah, because this is condenser. So seawater in, seawater out. So from here we can see the purpose of seawater over here as chill water, cooling water. To condense the steam into liquid form, then enter back to the boiler. to be heated up. Okay. Purpose using seawater, perhaps this power plant is next to the sea. Okay, thank you. Ying He and Lee Xiang Jun. Here not? Not here. Okay, so these are the only file that I received. The rest are not here. Okay, so basically the furnace, the appliances, combustion appliances, basically furnace. Okay, furnace, as what discussed by Lam Xuan over here, incinerator, as we discussed, burner being used in the incinerator as a whole system. Okay, and also boiler. For the boiler, okay, boiler furnace is used to supply the heat to heat up the water in the boiler. So basically, furnace is the main combustion appliances in industry. Okay, we can have burners. Burners, it runs only at limited temperature, but furnace can go higher at higher temperature, thousands of temperature. Okay. So for boilers over here, we have few types of boilers. Wait, I put slideshow. Okay, we have fire tube boilers. Here, the tube is placed horizontally, okay, in a boiler. The heat from the furnace, okay, it horizontally pass through the boiler to heat up the water inside the boiler. This one, the water tube is placed vertically inside the furnace. Okay, so water tube vertically inside the furnace. So the heat generated from the furnace will heat up the water pipes to convert from the liquid water into steam. Okay, so different type of boilers is depending on your process and also location of your plant and also the facilities that you have inside your plant. Okay, the types of boilers is depends to the position of the furnace, whether it is internally or externally fired boilers, and according to axis of the furnace, it can be vertical or horizontal boilers. Okay, number of tubes that you require, single tube or multi-tube. Single tube boilers means this one. Okay, you have only one cylindrical tube. So furnace, the hot stream horizontally placed in the boiler, okay, to pass through the boiler. Now it also based on method of circulation of water, whether you have natural circulation, that means based on gravity, okay, and forced circulation, you'll have pump, okay, you use pump. So it also depends according to the use, whether you require the boilers to be stationed at one place or the boilers will be mobile. Okay, perhaps you will need the boiler to move to another plant. So you will need to design the boiler according to your suitability. Okay, for boilers, there are a few factors affecting the selection of boiler. The quality of steam that you require, how much the steam that you want to generate per day or per hour. Okay, the accessibility of repair, the area, the cost, the erection facility. This one is the installation of boilers facilities. That means the facilities to lift up the boiler. Okay, fuel and water availability. Components of a boiler. Okay, this one you can read through. The most important part is, of course, the boiler shell and the combustion chamber. Combustion chamber where the combustion occur to produce the heat. Okay, the boiler shell is based on how much water that you want to heat up. Okay. Okay, these are the mountings. You can read through. This one, the accessories. Boiler accessories, there are a few types of, perhaps you have feed pump, air preheater, economizer, steam superheater, feed pump, and injector. Okay, economizer. Why do you think you need economizer? This is accessories. Certain plant they have this economizer. What do you think? Why do economizer being installed? What's the purpose to install economizer? Small? Small heat exchanger. What do you mean by that? Mm-hmm. Mm. They preheat the water so that you don't need too much energy in the combustion chamber in order to achieve the required temperature. Okay, when you reduce the energy, you can reduce the fuel. You can reduce the cost of buying the fuel. Okay, you can reduce the air intake and you can reduce the furnace design. Okay, this one you can read through for your own understanding. Okay, now fluidized bed combustion. We have few types of combustion. Fluidized bed combustion where we have fluidizing air pass through the raw material. Okay, in this case, we have coal and limestone as the feed. Okay, air being supplied from the bottom over here, fluidized through the combustion chamber, and the energy created will heat up the water. Okay, so here the main purpose is to heat up the water to generate the superheated steam. Flue gas condensation. Okay, this is a technology to recover energy due to condensation of water in the flue gas. It also used to clean the flue gas before being released. So here is the hot air. Okay, the flue gas passing through the scrubber. So it will scrub out the hazardous components. Then the water eventually, the water used to scrub, eventually it will be preheated. Okay, so you will have the preheated water over here. Okay, any question? Okay, for the combustion appliances, mainly focusing on the furnace and the boiler. Okay, you should read through and understand the type of furnace and the design of the furnace. And then the type of boiler. Okay, whether it is fire tube or water tube. And then vertical or horizontal boiler. Okay. And then basically that is related to this topic, the combustion appliances. Okay, any question? Okay, no question. I will proceed a bit on chapter 5, sustainable fuels. What do you understand from the word sustainable? Okay, this topic, sustainable fuels and combustion technologies, how combustion relates with the sustainable fuel. Okay, what do you understand from the word sustainable fuel itself? What is sustainable fuel? Why do you care whether it is sustainable or not? Mm. It won't deplete and it can sustain, it can be reused and sustain the environment. Okay, sustainable fuels, basically the source will be from the waste, okay, agriculture waste, perhaps biogas generated from the waste. Okay. Now there are few types of converting biomass into energy, into fuel. In this slide, there is thermochemical conversion and biochemical conversion. Okay, for the thermochemical, from the word thermochemical itself, it uses heat. Okay, it uses heat. Thermochemical, thermo is heat, chemical, chemical lah. So it involves heating with the chemical. These three types, combustion, gasification, and pyrolysis. Okay, for combustion, you will need at high temperature. So that's why it relates with the thermo. High temperature with fuel, either solid, gas, or liquid fuel. Then from this combustion, you can generate steam, okay, superheated steam, where the steam can be used to supply to the turbine. Okay, so from combustion here, the main energy produced is the heat. Directly from combustion is the heat, but when you use the steam to the turbine, it can generate heat and also the electricity. Okay, then for gasification, it produces gas. It has certain gas, producer gas or syngas. Okay, so from these gases, it can be used to supply to the turbine, where the turbine again will produce electricity. Okay, so the gas produced from gasification can be used also as fuel cell. Okay, fuel cell, the gas specifically will be the H2. Okay, to supply the fuel to fuel cell H2. Then from fuel cell, it will generate the electricity as well. Okay, the voltage, the current. Now from the gas, again, gas from the gasification. For example, you have methane. So that methane convert into methanol. You will have fuel. Okay, when methane convert into methanol, then you will have your final product as the fuel. So for gasification process, the products from the gasification process can be used for heat, electricity, and fuels. Okay. Pyrolysis liquefaction, where the product from the pyrolysis is gas, oil, and charcoal. Okay, this one later we'll go through in detail, the pyrolysis process. For the gas, it can be used to supply energy to the turbine, where again the turbine will produce electricity and the heat. Okay, for the oil, can be used as the fuel. Charcoal can be used as the fuel, solid fuel. Okay, and this charcoal can be used as solid fuel for combustion chamber. Now for biochemical, the word bio itself, it involves biological material. Okay, be it like biomass, it is from the plant. Agriculture waste from the plant. Okay, for this biochemical conversion, we have digestion and fermentation. Okay, digestion over here use the biological substance react with the chemical, you will get biogas. For example, animal waste. We incorporate microbes. So the microbes will utilize the biomass to produce biogas. Okay, yesterday, just to share with you, yesterday I went to IWK process plant. So they have plant use the sludge from the wastewater treatment, the sludge used for the biogas production. So that sludge, they incorporate with the microbe and will produce biogas. That biogas again will be used to generate power to their generator set. So the biogas used inside the plant only lah. They don't supply to outside. So from there, they can reduce the energy use. They have like 4 biogas reactor, if I'm not mistaken. 4 biogas reactor. So from the biogas reactor, biogas produced and the sludge they will send to they will dry the sludge, then the sludge will be used as fertilizer. Methane. Methane, yes. Okay, next fermentation, where we have, for example, agriculture waste, lignocellulosic material to convert into sugar. The cellulose convert into sugar. So from sugar, go for fermentation to produce ethanol, okay, bioethanol. So this bioethanol will be used as the fuel. Another method is the extraction from oil seed. Okay, this one from oil seed, you do esterification and you will get a biodiesel. Biodiesel, this can be used as a fuel as well. Okay. Wait, I want to share with you the image that I captured yesterday at IWK. Wait, on their biogas. Okay, here is their biogas reactor. This is the one that they supply the sludge after the water treated. So the sludge supplied here, then with the help of the microbe, it will generate the biogas. Okay, if you notice here, yeah, sorry. Okay, here, this is where they collect the gas, like balloon like. So the gas will go into here. All gas will be collected over here. Then those gas will go into filtration system where they will filter out the H2S and they separate the methane. Okay, that one, that process perhaps it is underground, so it's not shown over here. The what? The sludge, After this process, they will heat up, and then form composter or soil for agriculture. They also sell that one. Mm. Mm. But those soil is not used for uh, it cannot be used for tree that produce like fruits, non-edible tree, non-edible tree, like for landscape only, because those sludge perhaps might contain some contaminants. Okay, this is their SCADA system of the biogas. SCADA means their control room. Their control room. So they will monitor the system from their control room using SCADA. Here is this is the bioreactor. So this is the gas collection. Then the methane collected will be supplied to their genset generator to produce energy to steam up the boiler, to heat their boiler. Okay. Okay. If you have any opportunities for the visit to industry, please join. You will have a different, how to say, a bigger picture of what you have learned over here. Sometimes it's uh, not follow the book. It is case by case. Okay. Okay, for the biofuel, we have few types of biofuel. We have first generation and second generation. First generation, first generation basically the biofuels from food source like starch, sugar, animal fats, and vegetable oil. Food source. Okay, first generation is from food source. But for second, sorry. The most popular type of biofuel, the first generation biofuel is the biodiesel, vegetable oil, biogas, bioalcohols, and syngas. Okay, this is the example of the biodiesel where you have your raw material heat up sodium hydroxide or potassium hydroxide with methanol. Then you'll have reaction over here. Produce biodiesel plus glycerol. So from these two mixtures, you will need to separate them. You only want the biodiesel. Okay, the glycerol can be used to other purpose. Bioethanol is from lignocellulosic material. For first generation starch, for example, starch. Okay, and then the starch converted to sugar. The material to convert to sugar must contain carbohydrate, cellulose. Okay, cellulose convert to carbohydrate. So any material that contains carbohydrate, not all material can be converted into sugar. Those contains carbohydrate only. Okay, so from there, convert into sugar, then undergone fermentation with specific microbes to convert the sugar into bioethanol and CO2. So bioethanol will be used as the biofuel. Okay, for the second generation biofuel, just now the first they use food source. For second generation, it is not food crops. Okay, not food crops. So it comes from the waste, like such as grasses, okay, other type of waste, municipal solid waste, waste vegetable oil, waste cooking oil. That's why there are few factories that use waste cooking oil to convert into biodiesel. So those, I would say those contractors or those entrepreneurs that collect the waste cooking oil, this is their purpose, to convert into biodiesel. Okay. Okay, I'll stop over here because gasification need a lot of explanation. I stop to second generation biofuel. Any question? Okay, if no question, that's all for today. Thank you. We see you on Friday.